Okay, the torque is the ability of a force to rotate an object around an axis, and it's going to depend on two things. The first is, of course, how much force you apply. The second thing is where the force is applied. The farther the force is from the axis of rotation, the easier it is to rotate the object and more torque is produced. So you know this from opening or closing a door. If you go far away from the axis, it's going to be easier than if you go closer. So we'll do those little exercises when I get back on Monday. Torque is going to be symbolized by the Greek letter tau, and that's going to equal force times the lever arm. And this lever arm part is going to be the tricky part, so we're going to look at a couple of examples. Okay, the lever arm is going to be the perpendicular distance from the axis point to the force vector. And so we're going to go over that again many times, but go back to this anytime you're wondering, how do I draw this lever arm? If a torque causes a clockwise rotation, it's negative. Counterclockwise, it's positive. Think of the right-hand rule. We've been used to doing this. The units of torque are Newton meters, and you might recall work is also Newton meters, but remember with work, the force is always parallel to the displacement, while torque, the force is going to be perpendicular. A force acting at an axis cannot produce a torque. So if you tried to push at the axis of a door, the hinge, you're not going to open the door. Okay, so we're going to take a look at a couple of examples here. Yeah, that's not working so well. The first example is going to be, okay, this one right here, where I'm going to have a pivot point right here. I've got a bar right here, so 0.75 meters, and I have a force of 3 newtons that's going to be applied. Now the lever arm is very simple in this case, but we're going to follow the same directions. We're going to go from the pivot point. I'm going to have this force vector, and I can extend that force vector as much as I need to. In this case, it's pretty straightforward, but I'm going to go from the pivot. I'm going to draw a line that is perpendicular to the force vector, and that is my lever arm. So in this case, the lever arm is just 0.75 meters. So to find the torque, I'm going to take 3 newtons times 0.75 meters, and I'm going to get 2.25 newton meters. This thing would rotate this counterclockwise, and so that's where I get the positive. Okay. Okay. So we're going to go to number 2 here. Take a look at this. Now with number 2, what I'm doing is I'm going to apply the force perpendicular again, but 0.4 meters from the pivot point. So you notice again, the lever arm is going to be from the pivot point. I'm going to draw a line. I'm going to hit that force vector at a 90-degree angle. That's my lever arm. So 3 newtons times 0.4 meters. Notice I don't get as much of a torque. This will, again, be positive. Okay, that calculation goes with this one. It's a little more complicated when I have a force that's applied at an angle. So this is going to be a 20-degree angle, so that's a 20-degree angle. So the lever arm here, I didn't draw a very good 90-degree angle, but let's go through this. This force is a 3 Newton force. I'm going to extend that force vector, and you can extend that line of action as much as you need to. And then what I'm going to do is I'm going to go from the pivot point, I'm going to take it, I'm going to hit it with a 90-degree angle. So that's actually more the lever arm, not that thing. This is the lever arm right here. Now, that lever arm is going to be the sine of 20 degrees times this distance right here of 0.75. So what we get is the torque is equal to the 3 newtons of force times 0.75 times the sine of 20. And again, as I rotate this thing, this would rotate in a counterclockwise fashion, and so the torque is 0.75 newtons. I'm going to show you this one to realize that it doesn't matter if I apply it from 20 degrees this way or 20 degrees the other way. You are still going to have the same lever arm because you're going to go from the pivot point to the force vector at the 90-degree angle. I'm still going to get the sine of 20 times 0.75 times the 3 newtons. I'll get the 0.755 newton meters. Okay, there's a little bit more complicated ones here, so we'll take a look. If I have my example here for a basketball or a spool, counterclockwise and clockwise, but this is a force applied tangentially, 3 newtons of force. I'm just going to show you both ways here. Notice here that the lever arm is the radius, and that again is going to be because I've got a pivot point, axis of rotation, going to come over, I'm going to hit this with a 90-degree angle. So the radius is the lever arm. So I'm going to get the torque, I'm going to go 3 newtons times 0.15 meters, 0.45 newton meters. This will rotate it counterclockwise. This force would rotate clockwise, so you just get the negative there. Number 6, this is a pendulum. And again, looking at this lever arm, the pendulum is being brought up like this. It's going to swing back this way, and so we're going to get a clockwise rotation. That's why I'm getting the negative number there, right there. And this pendulum, we're going to take F sub g. The weight of the pendulum is going to be 2 kilograms times 9.8, 19.6 newtons. Okay, great. Now I need the lever arm. So the pivot point is right here. I'm going to go from the pivot point, I'm going to hit that force vector with a 90-degree angle. And again, I can extend that line of action, that force vector, as long as I need to in order for me to get the lever arm from the pivot and hit that at a 90-degree angle. This is my lever arm. So in this case, it's the cosine of 40 times the 3.5. And I'm going to get 52.6 newton meters. And it's going to go clockwise, and so I have a negative value. Number 7 is a crane, and this is your line of action because this is the weight of the crane that is being lifted. 50 kilograms times 9.8, get 490 newtons. This is going to be a clockwise rotation, and so I am going to take a negative and 490 newtons. Lever arm. Well, here's the force vector. I'm going to go from the pivot point, come across like this, hit that with a 90-degree angle. That's my lever arm. So 490 times 18 meters times cosine of 15 and negative torque. The last one is more complicated, so I'm going to expand it as much as I can here and take each one individually. So I have a board, and it looks like this is totally 11 meters at 5 meters and then another 6 meters here. I've got force 1 that's applied right at the pivot point. Well, we know that's going to produce no torque. I have force 2 of 60 newtons. I'm applying that one right there, 42 degrees. And then I've got force 3, 48 newtons at a 20 degree in that way. We're going to take each of them separately. Force 1 will produce no torque because it's right at the pivot point. Force 2, what I'm going to do is I'm going to take the force vector, I'm going to extend the line of action here. That's not the LA. LA is the lever arm. I'm going to go from the pivot point to the force vector at a 90-degree angle. That's my lever arm. And so if this is 42, then this is 42. And this will be the sine of 42 times 5. I can expand that a little bit more even, as you can see that. Okay, this lever arm right here, this is 5 meters, this is 42 degrees, this is 42 degrees, whoopsie-daisy. 42 degrees, and this is opposite this 42 degrees, so it's the sine of 42 times 5 times this 60 newtons of force here. Okay. And so if I just look at this force alone, and I'm going to erase a little bit more of this. If I look at this force alone, okay, my eraser just disappeared. All right, whatever. if I look at this force alone, this would cause a counterclockwise rotation, so that's why it's positive. All right. Oh, there's my eraser. Okay. So, force 3. We're going to go to force 3. That's 48 newtons. And 48 newtons, I'm going to take it a 20-degree angle. I'm going to extend this force vector like so. And then what happens is the lever arm is from the pivot point to the force vector. That's the lever arm for that force right there. So they're all separate. And for some reason, this is not erasing. So I'm kind of mystified, but all right. Anyway, this force is going to be 48 newtons. This is a 20-degree angle, so this lever arm is going to be the sine of 20 times this entire distance here, which is 11 meters. And if this force is the only force acting, it would rotate it counterclockwise. So I'm going to get a negative 181 newton meters. I add these all up, 0 plus 201 minus 181, I get a positive 20 newton meters.